Okay guys, so in this video I'm going to show you how to set up a service level OAuth provider system. So let's get into it. So a bit of a disclaimer first and foremost, this is not production code. I'm not trying to make this a full-fledged implementation with testing and all of this stuff, so make sure that you're not just copy pasting what I'm showing you now and just applying it in some code base somewhere, because odds are that you're going to get it wrong and something's going to get compromised. With that out of the way, let's talk about what we're going to cover. So we're going to talk a little bit about OAuth, just high level, what it actually is and what the deal is with the service level OAuth system, and then how we can create our own service level OAuth system. So something you may have seen while you're surfing the web is this little buttons that says something like log in with Google, log in with Facebook, log in with GitHub, etc, 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 right? So that is one form of OAuth that you are using. When you go to a third-party website of some sort, and you want to have a way to, like this third party, let's say they need something from you, like some type of information that someone else has, such as, say, Google, then OAuth is a very useful thing, because that's pretty much the perfect use case for OAuth. When two systems needs to talk to each other, or one third-party system needs to get information from another system, using OAuth is a very efficient method. Now, the common way is that you see, as you have seen yourself, you click, log in with Google, and then you need to make sure that you're logged in with Google, or that you need to provide some type of, you basically need to give your approval. Pretty much, you need to give consent that this third-party app you're using, that they have rights to check your inbox or get your user account information or whatever, basically. And what then basically happens is this exact thing. You have given that consent, and then the third-party system goes to Google with your credentials, or rather not with your credentials, but with a specific so-called, they're going to get an access token that they can use to retrieve records from that system. And that's one way of doing this, but what we're going to talk about today is the service level version of OAuth, which basically means that we're not going to have a user, but we're going to have two different systems that needs to talk to each other. In other words, we don't need the consent of a user to make this work. We really only need a way to be certain that a third-party system that we have approved is the client that is actually calling our API. And this is where a service level OAuth system is very useful, where you basically just have two systems that needs to talk to each other, or one system that needs information from another one, and you just want to be very, very certain that they are who they say they are. So let's just start walking through this a little bit. So here's my little server that I've started up, and here is the main application, which is just a little Express server with a bunch of information. I'm just going to scroll through this a little bit here, because we're going to touch on everything. So as you can probably first and foremost see here, that we have this little line here called public key, where I read a public key from the file system. So let's just touch on that, because that is the first and most important thing. So we have this endpoint that we call auth token, right? And this is the endpoint that is insecure, or like insecure in the sense that we don't have any validation requirement for our API on this endpoint, apart from the thing that I'm going to talk about, which is the JVT, right? Now, the reason why we don't want this is because if we have you can think about it yourself. If you have a third party that needs to use your API, these routes down here that are secured, I have this little middleware that I call is valid, and we're going to touch on exactly what this means in a moment. But basically what this thing here, this function does, is that it validates the incoming request. So you can't just call API version 1 users willy-nilly. We can try it. So if I do something like curl http 3000/API/version1/users, like that, I'm just going to get a message saying missing access token, because I don't have an access token. Now, what is an access token? Well, it's you can think of it as a hand stamp. It is something that we include in our request to this API that proves that we have gone here and validated ourselves. This system has said that, yeah, you have the right to access this endpoint or this resource. Now, this is where this all comes in, because I can call this endpoint whenever I want. It's just that I need to basically provide the correct credentials to get back my access token. It's very simple. You can think of it, this is the equivalent of you going to any website and entering your username and your password. It's the exact same thing. It's just that we're doing it system to system. So what's happening here? So we have a JVT verify call here where we basically check the query parameter and we are trying to get the claim parameter, or that's basically it. So in our claim we have a JVT string, and then we try to verify it using a public key. So we've created a private key and a public key pair in order to be able to assert that this JVT is from the client that we trust. You see, what's nice about this is that JVTs have one very powerful feature, one very useful property, and that is that you can sign them so that you are certain that the information that you receive over the wire hasn't been tampered with, it hasn't been mutated in any fashion or anything like that. Now, a lot of people use JVTs just with just a static secret. They have some random string, and then hey, that's the secret, and then that's the whole story, right? And sure, that is useful, and it is quite often. I mean, if you just have your own internal system, that's probably going to be good enough. But in this scenario, we have a third party that is a different entity from a different company or something like that. They're just, they're not in our internal system. So by doing this, we add another layer of security, because now we can sign it with an asymmetric key, where basically they create this private key and this public key pair, and then they give us this public key. So we have the public key. In other words, we have the power to decode a message that they have sent to us, and in this case it's just going to verify that JVT actually came from them. So what they're going to do is that they're going to sign their JVT with the private key, send the JVT to us, hopefully over TLS or some HTTPS at the very least, so that it's secure, and then it's going to arrive at us, and then we're going to read up this public key. Now I've just hard-coded this public key, but in a real live system you would of course have a connection, like they would have some client ID, we're going to look at that as well, and that's going to be connected to this key that they have given to us. And so, if you, in certain circumstances, if you go to, say, Google or something like that, and you want to set up your own service level account, they're actually going to generate all this for you, and you're just going to get that information immediately. But I wanted to keep it fairly simple. So they give us this public key, and now we can decode their JVT, or we can verify that this JVT is from them and that the information is correct, right? So this now kind of nullifies potential attacks from hackers, where a hacker could have gotten the JVT or done a man-in-the-middle attack and then changed the information somehow. Maybe they wanted to make a very powerful token that can do a lot of very dangerous stuff, and then they would have started using that token in their own request and basically compromise the whole system. But by doing this, it becomes extremely hard for them to do this, because it's not just a static string that we're signing with, so it's hard to brute force this or anything like that. And at the same time, what I really like about this is that since we only have the public key, if for some reason there would have been a lack of trust between us and the third-party system, they may be afraid that they are giving us some type of sensitive secret or something that we can use. Because remember, if we just use a static secret, then we could in theory sign our own JVT on their behalf, and pretend to be them and just send a message to somewhere where this JVT would also have been valid. But with this we can't, because we don't have the private key, so the signature will be wrong. So after that we create an access token. Let's have a look at that. So an access token is just a JSON object, or an object that has a scope, which is just a string. I'll show you these type aliases that I created here. And then we have a client ID, which is the ID that this third party have. This is how our system knows that, all right, this is the third party system that is contacting us. Right now I'm not using this for very much, but if we, as I said, had a real live system, we would have had at least the public key saved in a database where this public key would have been stored together with the client ID. And there's other things that we would use it for, but it's important to have some way of identifying the calling party, right? And then we have a TTL, or a time to live in seconds, just how long is this token valid for, and then when it was created, and then the value, in other words, the actual token string, the random value that we're going to create. And this is how we make it. We take in the client ID in a scope, and then we set the time to live, and then we create the start date, or when it was created, and then I create a little Well, you could make this even more random, but I just decided to get some random bytes and then base64 encode them. That's going to be random enough, right? And then we set the client ID and the scope. And yeah, once that's happened, we go to our service here, our access token service, and that's just this little thing here. I have this little services folder here, or like this direct, and this file here, where I use Redis for this. And the reason why I want to use Redis is because when we're dealing with access tokens like this, or token validation, it's going to be included in every single request. So we really want to make sure that that's performant, and using Redis is going to be a lot faster for this sort of work than using MySQL, Postgres, or MongoDB, or something like that, because this is going to run all in memory, right? Which is perfect. So we have our access token service here, which is just this little service here where we take in the Redis client, and then I use Promisify on Redis, the set and the get at least, because that's not supported by default. So now I have these promise returning functions, and then this is the whole service. It just creates an access token and it can find an access token based on the string that we input. And that's the whole story, right? So now we've created it, and then we return the JSON token response. So let's have a look at the script that does all of this. So let's try to do like the base case. We want to just get all the users, and let's just try that out, right? So here's my little script to do this. I just created a little client. So let's just pretend for now that this is a third-party system, like some other application somewhere. It could be one of your customers or something like that. So what they're going to do is that the first thing that they're going to do is they're going to create a token that has the scope of users. So in other words, they want to create a token that allows them to access resources that are restricted to the user level. In other words, the scope's whole purpose is to define a token's the resources that a token is allowed to be used with. It's kind of like, you can think of it as a hand stamp going into a carnival. You may have one hand stamp to just get in, but you may have another hand stamp to get into specific services or get things for free or things like that, or to show that you're a VIP. This is just a way for you to express different ways of locking down resources. So that's the first thing, and then they're going to include it into the authorization header. And then the standard is to say bearer, space, and then just the token, right? And that's pretty much all there is to OAuth. So let's have a look at getting that token. So here we read in our private key, as we were saying earlier. That's the benefit of having the JVT signature for this initial request to actually get the token, because it makes it much more secure. So we grab the private key. We create our request, which is going to be a client ID and the scope that we want, which is what we pass in here, right? Then we sign our JVT, and then that's pretty much it. And then we send the request with the claim, with this JVT string, and then we're going to get back our token. So let's have a look at that. Let's do get all users like that. And here we are. So now I first logged out the response, which is going to be this token that we have here. And then we just immediately use it in order to retrieve all the users. And we have 2 users, Fred and Barney. And that's pretty much, yeah, there. I can just show them. Like, it's just, I didn't want to set up an entire database for this little demo example, but I hope you get the get like the basic idea anyway. So that's the basics of how OAuth basically works, right? So you can, of course, also express more fine-grained things, where we're going to look at this is valid middleware in just a moment. But the thing I want to emphasize here is that you could, if you wanted to, if you want to be lazy about your API, you can say that, all right, we only have high-level scopes, such as users. In other words, you have a single scope that says users. And if you have that scope, you can do anything that has to do with users. And if you only have a single third party or 1 or 2 third parties, and you don't really have anything that is resource, like anything that is client specific, then this is fine. Then there's no reason for you not to give them full access to all the features. But if you want to allow them to lock down and say, hey, I want to get a specific user, not just any, I don't just want to list all the users, so I don't want to give that sort of power to a third party that they can do anything with my API. I want them to just be able to do specific things. Then you can lock it down even further. And this is what we're doing here. Here we're saying that, all right, you want to get a specific user, but you're not allowed to just get a user willy-nilly, or like you can't just request any user. You actually have to have a token that says that you have the right to get this specific user. Now in my implementation, and we don't actually do any validation, but let's say that you had several clients that could create users or update users on the same system. Now, some clients should probably not have access to grab users that were created by another client, right? You don't want people to mess with each other's data, right? So this is a way for you to actually lock this down even further. So let's look at how this actually works. Let's have a look here. So is valid, this is my little middleware here. You can just scroll through it, it's about 50 lines of code. So it's a higher order function where I take in an array of scopes and then it returns the request handler that we know and love from Express. And what it's going to do is that it's going to grab the authorization header. It's going to check if there is none. We're just going to return a 401 and saying that, hey, there is none. Then we're going to split on the space because the first element is going to be the word bearer and the second element is going to be the actual token, the token value. And then we go and do a lookup on this token. If there is no token, we say 404, we didn't find one. If the token has expired or like it's an old token that isn't valid anymore, we simply say that, hey, it has expired. And like that's kind of what we do here. We just grab the current date and we compare it to the actual time that the expiration time of the token. And then we go and take the scope of the token and we split because like the norm is to have a space separated string. That's pretty much how you express the scope. You just have like these words or these commands that you concatenate into a space delimited string, and that's how you parse it, or rather that's a very popular way of doing it anyway. And then we filter out all the things that are a template. We can see here, let's actually go back there. As you can see here, I have this little template string here where I'm basically trying to express that, all right, I have a parameter, like we're asking for a specific resource with this user, in this case it's a user, we want this user ID, right? So what I'm saying is that the scope should be users and then followed by that specific user ID. That's how I validate it, right? And that's the basic thing, right? You're asking for a resource, you have a token, you need to make sure that they are in line. So that you can't like go and get any resource for any user with the same token. You have to have a match between the resource you want and the token that you have, right? But I'm just filtering out these right now because I just want to check if all of the scopes that I have defined or the token that we found in our Redis database is including all of the scopes that we require in order to do this, right? And then we check if we can access the resource, which is very similar, where we just go through all the scopes and we make sure that every one of them follow this. So we have a scope, the index, and the reference to the array, and then we check if it's not a template, because we're basically just going over each of the scopes. We're basically looking if there is, because we wanted to work both for the scenario where we have a template like this, an ID, but also when we don't have one, right? So we're just going to return true if we don't find anything that is a template. So any element that isn't a template, we just return true for. But if we find something that is a template, then we want to do a switch. We want to replace that element on that template string and just check that it matches the thing that we have in the token, right? So we grab the resource name. In other words, like if the element we find is a template, then the previous element was the resource name, because the structure that we assume is this, that it's a resource and then the ID. And then we do a lookup in the scopes of the token. We just find the name of the resource, like this resource name, and then we add one to it. So we're on the actual ID. That gives us the resource index or the resource ID index, and then we get that. And then we replace the colon, like this colon here, so that the template string is just the name without the colon. And then we go to the parameters and extract the parameter ID. So we check the parameters, and then so that we have the same parameter as we specified up in our application. And then we make sure that both of them are defined. And then we check that they are equal. That's it. And then, I mean, we could make this a lot more elaborate. I mean, as I said, if we had some lockdown system or shared resources, we would like check that, okay, this user here or this product or something like that was created by this client. Is this the client that is calling? Is it Tuesday? We could validate this as much as we wanted to if we want to go even further. But this is the base, like the base case. You have a resource that you want to access. You have a token. They both need to have the same scope. Otherwise, you're not allowed to go in there. And then if they both are true, we return next. Otherwise, say it's invalid, doesn't contain the needed scope. And yeah, that's pretty much it. Oh yeah, and like this is template function is just a little bit of a convenience thing, because I think that's more expressive than having the regex in these places. So that's pretty much it. So that now leaves us with this little script here where we can say node get user, and we say get user 1, and here we got Fred, and then we can get Barney. If we get we go and check the script, it's just going to take in the my argument here and set it and create a token with this scope here. So if I do something like this, though, I create a token that has a scope to something else, and I try to do the same thing, it's going to return token does not contain needed scope, because basically what I did now is that I created a token that has a user that specifies that it wants to access the users and an element like a user that has the ID of the string ID, but I don't actually give it the number that I want. Then this is an invalid token, right? As we were saying, I'm trying to go to the user with the ID of 1, but I don't have a token that is valid for a user with the ID of 1. Right, and then finally I'll show you the last level of this, well, not the last level, but this is also fairly, a pretty cool way of doing this. And that is to actually lock down, not only, you can think of it as a stair of specificity, where I say, okay, this is high level, I just access user resources if I want to list something or something like that, easy peasy. But then I also can say, all right, I want to lock it down even further. I want to just give you I just want a token that is specific to this user to be allowed to go into this route. And here it is. I'm going to say that you need to have a token that is valid for on the users, a specific user, but also just for this specific operation. And you don't have to go this far, but this is depending on what type of third party you have. Maybe they want it to be this secure, because if this token gets compromised, imagine what happens if you have a global token that can do all the things. Well, then you give the hacker maximum power, but with this you give them the minimum amount of power. This token, even though they get it, they can only for 1 hour, they can only access this specific resource and perform this specific operation, right? So if we see the delete user, it's pretty much the same deal. Once all of this, it's almost the exact same thing. It's just that now I need to specify that this is going to be a delete user request. And in my validation thing, I would have basically done the same. It's the same song and dance. It's just that when I validate, I need to think about, okay, what do I actually want here? How much validation do I need to give somebody before they're allowed to create a token of this type? And yeah, this is a very a high-level example of how you can implement your own Oauth provider system if you're making a public API, or it doesn't have to be a public API, just an API that you're selling to some customer or they need to integrate to you. And yeah, these are a few good practices to keep with you. Hopefully you found this useful. Have a great day.